है एवरीवन, वेलकम टू एनसीईआरटी ऑडियो बुक। आज हम हाइड्रोजन का नेक्स्ट पार्ट हाइड्रोजन पेरोक्साइड से रीड करेंगे। 9.7 हाइड्रोजन पेरोक्साइड H2O2। हाइड्रोजन पेरोक्साइड इज एन important chemical used in pollution control treatment of domestic and industrial effluents. 9.7.1 Preparation. It can be prepared by the following methods. 1. Acidifying barium peroxide and removing excess water by evaporation under reduced pressure gives hydrogen peroxide. 2. Peroxide disulfate obtained by electrolytic oxidation of acidified sulfate solutions at high current density on hydrolysis yields hydrogen peroxide. This method is now used for the laboratory preparation of D2O2. 3. Industrially, it is prepared by the auto-oxidation of two alkyl anthraquinols. In this case, 1% H2O2 is formed. It is extracted with water and concentrated to 30% by distillation under reduced pressure. It can be further concentrated to 85% by careful distillation under low pressure. The remaining water can be frozen out to obtain pure H2O2. 9.7.2 Physical properties. In the pure state, H2O2 is an almost colorless, pale, very pale blue liquid. Its important physical properties are given in table 9.4. H2O2 is miscible with water in all proportions and forms a hydrate H2O2 dot H2O melting point 221 Kelvin. A 30% solution of H2O2 is marketed as 100 volume hydrogen peroxide. It means that 1 milliliter of 30% H2O2 solution will give 100 ml of oxygen at STP. Commercially marketed sample is 10 volume, which means that the sample contains 3% H2O2. 9.7.3 Structure. Hydrogen peroxide has a non-planar structure. The molecular dimensions in the gas phase and solid phase are shown in figure 9.3. 9.7.4 Chemical properties. It acts as an oxidizing as well as reducing agent in both acidic and alkaline media. Simple reactions are described below. 1. Oxidizing action in acidic medium. 2Fe2 plus 2H plus 2H2O2 gives 2Fe3 plus 2H2O. PbS plus 4H2O2 gives PbSO4 plus 4H2O. 2. Reducing action in acidic medium. 2MnO4 plus 6H plus 2MnO4 minus plus 6H plus 5H2O2 gives 2Mn2 plus 8H2O plus 5O2. HOCl plus H2O2 gives H3O plus chloride plus O2. Oxidizing action in basic medium. Fe2 plus H2O2 gives Fe3 plus OH minus. Mn2 plus H2O2 gives Mn4 plus OH minus. Reducing action in basic medium. I2 plus H2O2 plus 2OH minus gives I minus H2O and oxygen. MnO4 minus plus H2O2 gives MnO2 oxygen, water and OH minus. 9.7.5 Storage. H2O2 decomposes slowly on exposure to light. 2H2O2 gives H2O plus O2. In the presence of metal surfaces or traces of alkali present in glass containers, the above reaction is catalyzed. It is therefore stored in wax-lined glass or plastic vessels in dirt. Urea can be added as a stabilizer. It is kept away from dust because dust can induce explosive decomposition of the compound. 9.7.6 Uses. Its wide-scale use has led to a tremendous increase in the industrial production of H2O2. Some of the uses are listed below. 1. In daily life, it is used as a hair bleach and as a mild disinfectant. As an antiseptic, it is sold in the market as perhydrol. 2. It is used to manufacture chemicals like sodium perborate and percarbonate, which are used in high-quality detergents. 3. It is used in the synthesis of hydroquinone, tartaric acid, and certain food products and pharmaceuticals, cephalosporin, etc. 4. It is employed in the industries as a bleaching agent for textiles, paper, pulp, leather, oils, fats, etc. 5. Nowadays, it is also used in environmental green chemistry. For example, in pollution control treatment of domestic and industrial effluents, oxidation of cyanides, restoration of aerobic conditions to sewage waste, etc. 9.8 Heavy Water D2o. It is extensively used as a moderator in nuclear reactors and in exchange reactions for the study of reaction mechanisms. It can be prepared by exhaustive electrolysis of water or as a byproduct in some fertilizer industries. Its physical properties are given in table 9.3. It is used for the preparation of other deuterium compounds. For example, CaC2 plus D2O gives C2D2 CaOD का whole 2. SO3 plus D2O gives D2SO4. Al4C3 plus D2O gives CD4 plus LOD का whole 3. 9.9 Dihydrogen as a fuel. Dihydrogen releases large quantities of heat on combustion. The data or energy released by combustion of fuels like dihydrogen, methane, LPG, etc. are compared in terms of the same amounts in mole, mass and volume are shown in table 9.5. From this table, it is clear that on a mass for mass basis, dihydrogen can release more energy than petrol, about 3 times. Moreover, pollutants in combustion of dihydrogen will be less than petrol. The only pollutants will be the oxides of dinitrogen due to the presence of dinitrogen as impurity with dihydrogen. This, of course, can be minimized by injecting a small amount of water into the cylinder to lower the temperature so that the reaction between dinitrogen and dioxygen may not take place. However, the mass of the containers in which dihydrogen will be kept must be taken into consideration. A cylinder of compressed dihydrogen weighs about 30 times as much as a tank of petrol containing the same amount of energy. Also, dihydrogen gas is converted into liquid state by cooling to 20 Kelvin. This would require expensive insulated tanks. Tanks of metal alloy like NaNi5, TiTiH2, MgMgH2, etc. are in use for storage of dihydrogen in small quantities. These limitations have prompted researchers to search for alternative techniques to use dihydrogen in an efficient way. In this view, hydrogen economy is an alternative. The basic principle of dihydrogen economy is the transportation and storage of energy in the form of liquid or gaseous dihydrogen. Advantage of hydrogen economy is that energy is transmitted in the form of dihydrogen and not as electric power. It is for the first time in the history of India that a pilot project using dihydrogen as fuel was launched in October 2005 for running automobiles. Initially, 5% dihydrogen has been mixed in CNG for use in four-wheeler vehicles. The percentage of dihydrogen would be gradually increased to reach the optimum level. Nowadays, it is also used in fuel cells for generation of electric power. It is expected that economically viable and safe sources of dihydrogen will be identified in the years to come for its uses as a common source of energy. Summary: hydrogen is the lightest atom with only one electron. Loss of this electron results in an elementary particle, the proton. Thus, it is unique in character. It has three isotopes, namely protium, deuterium, and tritium. Amongst these three, only tritium is radioactive. In spite of its resemblance both with alkali metals and halogens, it occupies a separate position in the periodic table because of its unique properties. Hydrogen is the most abundant element in the universe. In the free state, it is almost not found in the Earth's atmosphere. However, in the combined state, it is the third most abundant element on the Earth's surface. Dihydrogen on the industrial scale is prepared by the water-gas shift reaction from petrochemicals. It is obtained as a byproduct by the electrolysis of brine. The HH bond dissociation enthalpy of dihydrogen 435.88 kJ per mole is the highest for a single bond between two atoms of any elements. This property is made use of in the atomic hydrogen torch, which generates a temperature of 4000 Kelvin and is ideal for welding of high melting metals. Though dihydrogen is rather inactive at room temperature because of very high negative dissociation enthalpy, it combines with almost all the elements under appropriate conditions to form hydrides. All the type of hydrides can be classified into three categories: ionic or saline hydrides, covalent or molecular hydrides, and metallic or non-stoichiometric hydrides. Alkali metal hydrides are good reagents for preparing other hydride compounds. Molecular hydrides B2S6, CH4, ammonia, water are of great importance in day-to-day life. Metallic hydrides are useful for ultra-purification of dihydrogen and as dihydrogen storage media. Among the other chemical reactions of dihydrogen, reducing reactions leading to the formation of hydrogen halides, water, ammonia, methanol, vanaspati ghee, etc. are of great importance. In metallurgical process, it is used to reduce metal oxides. In space programs, it is used as a rocket fuel. In fact, it has a promising potential for use as a non-polluting fuel of the near future hydrogen economy. Water is the most common and abundantly available substance. It is of a great chemical and biological significance. The ease with which water is transformed from liquid to solid and to gaseous state allows it to play a vital role in the biosphere. The water molecule is highly polar in nature due to its bent structure. This property leads to hydrogen bonding, which is the maximum in ice and least in water vapor. The polar nature of water makes it a very good solvent for anionic and partially anionic compounds, B to act as an amphoteric acid as well as base substance, and C to form hydrates of different types. Its property to dissolve many salts, particularly in large quantity, makes it hard and hazardous for industrial use. Both temporary and permanent hardness can be removed by the use of zeolites and synthetic ion exchangers. Heavy water D2o is another important compound which is manufactured by the electrolytic enrichment of normal water. It is essentially used as a moderator in nuclear reactors. Hydrogen peroxide H2O2 has an interesting non-polar structure and is widely used as an industrial bleach and in pharmaceutical and pollution control treatment of industrial and domestic effluents. Okay, that's all for today. Hope you like it. Please subscribe for more such videos. Thanks.